Okay, and I don't know if Annetta will share the slides. If not, I can do that. Oh, thank you, Annetta. Okay, hi. So yes, my name is James Pope, Senior Research Associate here at the University of Bristol. And I will give the presentation on SYNERGIA, a secure platform for cloud IoT applications. I'll work on this along with Francesco Raimondo, my colleague, and George Economou, Rob Pihotsky, and Ryan McConville. Next slide. Okay, I think we went one too far too past, maybe, if we can go to the preview. There we go. Okay, so this is, and I should say, as I get into the talk, this is above the physical layer, so to speak. So maybe the first couple of talks and maybe subsequent talks will be focused perhaps on the physical layer for communication. This is generally going to be above that. So we're looking at really kind of cybersecurity and also machine learning aspects. So if you could, yeah, the previous slide, there you go. And so this is actually an architecture that's been around for some time, which is really this IoT cloud architecture with a back end, edge devices, and endpoints. So the back end, it would traditionally be where the central management would take place, and you would analyze all of the data there. The edge devices are things that are going to be pushed out. As an example, edge devices might be on lampposts in a city for a smart city application. So they would be distributed around a city. The backend might just be one data center, perhaps within the city, analyzing the data. And then the endpoints would be sensors communicating with the edge devices, collecting the data. These are typically resource constrained, and we normally refer to these as the Internet of Things, the IoT devices. So they would communicate their data to the edge, which would could analyze it. I'll talk about that in a little bit. Or it could be analyzed in the back end. So that's really the architecture, and we'll have a picture coming up. So this has been around for a bit, and certainly this architecture has been employed in a number of areas. There's still a number of challenges. Interoperability, which have actually been, Dan had mentioned previously, security, really end-to-end security, and more recently, privacy between the components. And all of these remain difficult problems. So one of the things we're looking at is to communicate from those devices in a secure, reliable, resource-efficient way. So next slide. So the project consists of a consortium of industry partners, and so we're split into 5 work packages. The University of Bristol is on all 5 work packages, which it makes it a bit challenging. But we're also working along with Toshiba. Toshiba has the initial infrastructure. They have an edge device called an Umbrella that they have deployed. I believe they have 230 within Bristol deployed with 1,500 sensors over about an 8-kilometer area within the South Gloucestershire area. We're also working with Mac Limited. They're working on some of the putting together some of these sensors for the project. As well as, I should say, they're just COTS. They're buying COTS sensors and integrating it. So we're also working with Smartia. Smartia is bringing in federated machine learning. They have some expertise in this area. And IOE Tech has expertise in key exchange, secure key exchange. And finally, Configure Things has expertise in basically defining data flows and who can see what. So we're working along with, this is the consortium, and so next slide. So here's the overview. So we have and again, this is obviously more simplified, but the back end, you have edge devices and endpoints. We are going to use basically containers. I should point out that what has come about, and again, I would say, won't say it's new, but this idea of having containers running different applications on the edge. And not only do you have that, these containers and the applications running within them are actually different organizations. So on some edge, you may have containers from different organizations running on them. So this actually introduces quite a serious security problem, which is if a container misbehaves, how do you detect that, and then what do you do? So this is one of the research areas we're looking at, is how to address this problem. But as you can see here, we also have the endpoint. So we're actually going to set the system up, I should say. SYNERGIA, we're actually going to set up this system, we already have the 802.15.4 system in place collecting sensor data on an edge device, the umbrella that Toshiba has. And we're getting that now integrated with their backend. We're doing for security, and we're kind of depicting it here, is that we're using basically pre-shared master keys to do a key exchange or key transport, if you will, to create a session key. So that's generally the idea for authentication, and then ultimately to provide the security, end-to-end security. We haven't done it yet, this shows, but the umbrella device also has a LoRa receiver. And so we are going to integrate that with the project as well. So, and before we leave the slide, one of the concerns, one other area of concern, so we have really two areas, and this will come up on the next slide, but it's really this container escape, detecting that a container is doing something malicious. And that will actually take place on the edge device. So we're going to do the machine learning on the edge device. There will be a centralized model on the back end looking at this. So this actually creates what we call the federated machine learning use case, where we're not going to communicate the data from the edge device to the back end about the model, the AI model that has learned about container escape, but they will actually exchange, if you say, model parameters instead of the data. And that provides basically some privacy for users on the edge. The other area we're going to look at for this project is data drift. So you can imagine that these endpoints are out there within the city or wherever they're deployed, and somebody is manipulating it. That could be just normal, device going bad, malfunction, but it could also be somebody that is manipulating the device in a certain way. And so we're also going to use machine learning for that to try to detect that, and we call that data drift detection. So next slide. So we're going to develop and demonstrate this design, end-to-end design with resource-constrained devices. We'll provide use with the distributed capability at the edge as a service. And so, as this points out, we're also going to provide edge-based artificial intelligence for cybersecurity for these systems, specifically this idea of container escape. So next slide. So we have two demonstrations planned, one in January coming up soon, and then one in November. We're actually going to do the demonstration at Future Spaces up on the UE campus. And so the use case is actually going to be a kind of a smart building application, or use case, I should say, maybe trying to find the number of occupants in a room and determine that. We're going through that, and we're actually using the sensors to help support that. I just do want to point out that's not really the focus of the project. The focus is to really use that as a use case, then go out and look at both of these other issues, a compromised container or a compromised endpoint with container escape or data drift. So next slide. So the two important research questions, as I've already alluded to, are going to be the container escape for anomaly detection. And again, there's a Jetson Nano on the umbrella edge device, so we'll use it to help with the AI training and prediction, but training is the hard part. We're currently going to use basically autoencoders to basically determine what normal means, a normal operation, and then use that to determine abnormal cases. And then there will be a centralized model that they will have to communicate to, and that's where the federated part comes in. We're also going to look at data drift anomaly detection. This one will not be restricted. We will actually be able, this will be more of a distributed machine learning case. And we're currently looking at graph neural networks, possibly spatial temporal graph neural networks to look at detecting this anomaly. The other research thing we are looking at, I would say this more traditional, certainly not some of the more other approaches in cryptography. We're looking at more traditional cryptography, specifically key exchange. We're currently doing key transport when you get into IoT networks, life gets hard, so to speak. And so we are certainly looking at that and trying to adapt existing key exchange protocols for these resource-constrained devices. And we will also look at not just key transport, but key agreement protocols such as elliptical curve Diffie-Hellman to basically to exchange session keys as well. That's more difficult with IoT devices, but they have become a little more capable, and we will just see how far we get with that. So we would also like for this to work for both mesh networks, if you will, 802.15.4, as well as star topologies such as LoRa. So that is the next slide. So this is just how we basically adapted something like Kerberos, which is a key transport mechanism, really to our use case and for IoT devices. And we've gotten it down to a few message exchanges. And so it's basically there's mutual authentication between the endpoint and the edge device using this master key. I will also say one other thing. The edge device, the architecture is so that the edge device can go away. Obviously, the endpoints will be in trouble, but there's nothing stored on the edge device. So we wanted to make sure that there were no persistent storage problems or security problems with these edge devices. So like I said, that's the key transport. We are currently adding a key agreement scheme to this as well. So next slide. So here's kind of a depiction of what the container escape is. This edge device is really the umbrella edge device from Toshiba, and it has a number of interfaces here, as you can see. And what we want to do is actually, what we are doing, in fact, the submission's actually tomorrow, but we're pretty much done with the paper. We've actually created a data set, container escape data set, where we set up multiple containers. One of the containers collecting IoT sensor information from from three NRF endpoints through the NRF dongle. And we have several other containers running, and specifically we have a privilege escalation attack container running and a denial of service attack container running. And so what we do is we go through while we're we're logging all of this, and then we initiate one of these attacks, and we have it actually partially annotated. And for those of you who don't know, for machine learning, at least particularly supervised machine learning works quite well if you have annotated data. It's not always easy to get annotated data, and so we have gone through and helped provide this, and so we provide this data set for Container Escape that we're using on the project, and we're going to open source it hopefully within the next week or two. So that's the Container Escape, and then next slide. Along with that, this is also just using the data from the Container Escape to see how we might be able to detect it. As I mentioned earlier, we were using autoencoders to do the anomaly detection, and those are working fairly well, but we're also looking at other techniques. This one, frankly, is not a great technique, but it's somewhat interesting in how it's done. We basically take the audit D log files that were captured during the Container Escape, and what you can see here is we transformed the audit D file into a graph. And this one specifically on the left here is a process graph. The nodes colored, and so each node here is a process. And we're showing the parent-child relationship of the processes. The nodes in red are the processes that were part of the attack. And then the ones in gray are normal. They were not part of the attack. And so we've had this kind of annotated, so to speak, in some fashion. And we said, okay, well, can we use this to try to make predictions just based on the graph alone? I will have to say that the process graph does not have a lot of information in it. We're looking at other ways of transforming the audit D data into a more informative graph. But even with this graph, this process graph, we basically transform it into a node embedding, is what it's called, into 128-dimensional space. And then we then project it down into a two-dimensional space on the right that you can see here. And it's well clustered, and we then basically use this to train a supervised machine learning algorithm, logistic regression. The upshot of it is that we used only 10% of the for training data, and then it got a 97% accuracy on the remaining data. And so this really can help people annotate data, and this is what's called semi-supervised machine learning. So we certainly plan on doing more with it, but certainly it shows the utility of the Container Escape data set. And that's currently where we're at. So our next steps really are to move on to the data drift, continue to look at Container Escape, move on to data drift, and also to advance key exchange for IoT networks. So in conclusion, that's it. If they're ready to take any questions.
Yeah, okay, thanks very much, James. So have we got any questions from the audience? I've got one or two. I don't see any in the chat yet. So let me ask one to start things off. So as a sort of non-expert in this area, how would you say, in terms of if this was implemented for real, what kind of impact would a user feel if everything worked as you wanted it to work?
Yes, from a user's perspective, I think you would first, you would be able to deploy applications. You would be able to deploy your containers and your endpoints, and you would be able to do it, how can one say, with the security assurance that your data from the endpoint all the way to when you analyze it, wherever that is, typically the back end. It could be on the edge device as well, though, that you would have this assurance that it has not been tampered with. And so you would get that security. We're adding a message integrity checks to it as well. So this is what the user would experience if there were an attack. So, one of the problems, if you can't control the container next to you, right? Somebody else can. A unfortunate side effect of this, if somebody did compromise one of those containers, your application, your container, that edge device would be shut down. But really, Kubernetes, it's an orchestration, container orchestration. So you would be moved to another edge device. There would still be some loss of data, but these are the things that you would expect that the system should be able to provide, at least from an end user's perspective, that they would be looking for. So hopefully that answers your question.
Yeah, I think it does. Yeah. Okay, I think we better, in the interest of time, we're going to move on. Thanks very much, James.